All right, I'm back again. Um, I want to get humbled a little bit, you know. I want a harder problem. So let's just do let's do a medium problem in dynamic programming. See if I get humbled here. Give me something I haven't done before. Ha, 39.6. All right, perfect. This is gonna suck. All right. Well, hopefully this is kind of what I'm looking for here. All right, positive affirmations. I'm going to explain the problem well. I'm going to figure out how to do it. Not too bad. Not even explaining this well right now, so that's great. All right, whatever. Okay, here we go. Given a string S, you need to partition it into one or more balanced substrings. For example, if S is blah blah blah, then yeah, I get it. The unbalanced substrings are bolded. The unbalanced substrings are bolded. Where's the bold? I don't see the bold. L description. Return the minimum number of substrings that you partition S into. Okay. So. Okay. Alright. A balanced string. Yeah, I know. Okay. Alright, so yeah, it seems, I guess, like dynamic programming. I think our state can be determined by the current index that we're at in S. So our DP function, I'm gonna do top-down DP with the memoization, because I'm a scrub. And so, but basically, it's gonna be one-dimensional DP. It should just take the index that we're at in S, I think, and then return the minimum number of substrings I can partition my substring from I to the end of the string into. So let's say like dp0 is going to be the whole thing, and this will be my return value at the end. But dp like 4 would be what, 0, 1, 2, 3, 4. So dp4 would be like how many minimum strings that I can partition this into. Wow, I can't talk. Yeah. So I think that makes sense. So if I is the length of S of base case, I think we should return 0. 0 here. Alright. So hold on. Let me think. I'm getting confused. So at 0 here. Right. Okay, so I want to, so like in this first state, dp0, right? What I want to do here is start here at 0 and then see like, is 0, 1 a balanced substring? If it is a balanced substring, then this could possibly be a valid path to go down in my decision tree. So fa will be my current substring, and then the rest of this I will use my dp function to calculate the minimum number of balanced substrings that I would need to, you know what I'm trying to say, right? So what I need to do is, so my I in this state is 0, so I'm starting at F, and I need to go from F all the way till the end of my string S And if I ever have a balanced substring like FA or FAB or FABC, when that's balanced, then I can make a recursive call on the rest of the string. And then I got to add 1 somewhere to account for this partition that I'm doing right here, FABC, and then I would just add the number of partitions that I'm doing here. Yeah. So, and now the only concern that I'm having here is like, it's gonna be n squared because what's the easiest way for me to check if this current substring I'm observing is balanced or not? I don't know. So the way that I'm thinking right now is just O of n. Like I can just go through it and make sure it's balanced. Maybe there's an easier way, and I can bring my solution down to O of n. But I think I'm gonna have O of n squared solution, because my I can have n states, and then within each state I would be doing O of n work to check if this current substring is balanced or not. But yeah, I don't know. Let's see. So essentially though, what I'm trying to do here is right. For j in range from I to length s, I need my counts, and this will be just like this. Sure, that's fine. And actually, I'm going to use a default dict. Alright, so counts sj plus equals 1, and then if balanced, I don't know how I'm going to do this yet, but if it's balanced, then my memo at I is going to be the minimum of the current memo I. Nah, let's not do that. Let's just do like results here, and we'll make it infinity. Then res is going to be the minimum of the result, or I'm taking this current balanced substring because it's balanced, and then I'll be doing dp of j plus 1. Memo I equals res, return res. Turn dp at 0. I think this is the general shape. Now the only thing here, I just need to make sure I'm how can I do this efficiently? I don't know if there's a way to do this efficiently. Let's create another function. Def is balanced. This is going to take my counts, and we'll do for k, well, no, for v, and there's probably a better Pythonic way to do this, but I don't know of one, so don't know. V in counts of values, if count is none, count is going to be v, otherwise if count is not equal to v, turn false, turn true. I mean, this is, yeah, this should work. Self dot is camel case in Python, lol. Come on, n squared, work, n squared, n squared, n squared. No. Yes. Yes. N squared. And so I don't, so yeah, top down, probably would be better. Well, will be better because, you get rid of the call stack for all these recursive calls to my DP function. But sometimes with bottom up, you can use like the rolling space optimization, but I don't know if you can do rolling space here because we have to go back with this loop, like for j in range I to length of s, and so we potentially have to go all the way back down, because like the way that if I were to do a bottom up solution here, the way that I'm iterating, my I is digging all the way down to the end. My I is going to dig all the way down to length s, right? So this is my base case when I is length s, and then I'll start working my way back towards 0. But there's the chance here where I will have to access dp of j plus 1, and then j could be like all the way towards the end of my dp array. So I can't reduce the space here. I don't think I can. Yeah, because I'm gonna have to jump across. I might have to jump like all the way across my DP table. Should I do the bottom up solution? Yeah, why not, man? Let's get better at this stuff. So, I have a length of s elements in my table. I'm lying. No, I have length of s plus 1. So, something times length s plus 1, and the base case is 0, so like, I guess this does work out. And then I'm going for I in range of length of s minus 1, minus 1, minus 1. What am I doing? Well, I can kind of copy this part, can I? And then like later I'll return dp0, and so this will be j in range this should be dp of j plus 1. Probably missing something, but let's see. Oops. Turning 0 here. Why is that? Because I'm never setting my results. dp at I is equal to res. Is bottom up better? Let's see. Yeah, slightly. Let's see the best solution. Because you're using, maybe it's better because you're using an array or a list to access the counts rather than a dictionary, which has slightly more overhead. And I'm using a default dict, so even more slight overhead. Yeah, alright, buddy. What's happening here? But yeah, he still has this nested for loop situation going on, so I think I'm alright. Well, yeah, I think that's it for the video. Thank you for watching.